All right, so continuing on with the examples for 4.4 for using the quadratic formula to solve a quadratic equation. Um, so we're going to start with this one, 9x squared. 9x, interesting. 9x squared plus 12x equals -4. Okay. So first of all, we know that we're going to use our quadratic formula, negative, or x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so first of all, I need to have this written in ax squared plus bx plus c form, and that just means that I want to have it equals 0, right? So that just means I want to have everything on one side. That's an x there, sorry. Okay, so I'll add 4 to both sides, and then I have everything that's not a 0 on one side and the 0 on the other side. And then I can start substituting in my numbers. Okay, so my b value is positive 12, so I get negative 12 plus or minus the square root of 12 squared minus 4 times 9 times 4 all over 2 times 9. Okay, and just go ahead. Once those are substituted in, once you know a, b, and c, it's really easy to find your solutions. Negative 12 plus or minus the square root of 144 minus 144. Interesting. Okay. So negative 12 plus or minus the square root of 0 over 18. We don't have to worry about that anymore, right? In fact, we're getting rid of our plus or minus as well, which means we're only going to have one root here. Okay, one solution to this equation. So the solution to this equation is x equals negative 2 over 3. Okay. We could have just looked at the discriminant initially. Okay, the discriminant is b squared minus 4ac. So when we had plugged those values in and got 0, we would have known that we're only going to have one real root. Okay, because we don't have to worry about the thing after the plus or minus anymore. And it's the plus or minus that gives us two different roots, because you can go in the plus direction or you can go in the minus direction. And we'll just check this, make sure that it works out. Okay, by substituting that x value back into our equation and making sure that it still equals 0. So I put a question mark on top there because I'm just making sure. Okay, so square negative 2, you get 4. Square 3, you get 9. Okay, this becomes negative 24. Say 12, 24, but I write 12. Negative 24 over 3 plus 4 may equal 0, does it? Let's see. Right, so this becomes 4 minus 8 plus 4 equals 0. Okay, and so 4 minus 8 is negative 4 plus 4 is 0, so we know that it worked out, and that completes our check. Okay, and we'll just do b the same way, and b is already written in ax squared plus bx plus c form. Note that a is 5, b is negative 7, and c is negative 1. Okay, so when we put that into our equation, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, we get negative 7 is just a positive 7. Okay, b squared, that's negative 7 squared minus 4 times 5 times negative 1. Okay, all over 2 times 5. Okay, equals 7 plus or minus the square root of 49. Okay, we're subtracting a negative here, so plus 20 all over 10. So 7 plus or minus root 69 over 10. Okay, and if you put that in your calculator, you can just, you do it separately, right, to put it in your calculator. So you go 7 plus root 69, okay, divide that by 10, and you're going to get 1.53 approximately. Okay, and then over here you put that 7 minus root 69 over 10 into your calculator, and you're going to get approximately negative 0.13. Okay, you can substitute those numbers back into your calculator, and you should get close to 0, although because you rounded, it might be a little off. Okay, but pretty close. All right. And you can also check that on the graph by graphing it and looking at where the roots are.